Welcome back to the University of Queensland School of Architecture Introductory Series to Rhino and Grasshopper. Now we're going to pick up this from the previous core video, and what I'm going to do is set up a variable where we can offset it from this corner and actually offset it from the tower itself. So again, it's just simple arithmetic and geometry. So in the first instance I'm going to move it this way, so I'm going to set up a number slider through here. And I'll call this offset from southwest corner. I'll give myself a maximum range of say 6,000. Okay, and I'm going to do another. I'll do just copy that and do this offset from core offset from tower. Okay, we're going to move this corner first from there. So to do that we need to go in an X direction. That will be negative, and so we'll pop that to there. Offset from southwest corner, so that goes into there, there. We're going to move that point here to there. Okay, so we've got a point here, and now we're going to have to move that point out here again. So let's just move this over to here, and we'll do a move again. I'll pop that there because we're going to need this to feed into these two things over there. So we're going to move the point, we're going to move it in a Y direction, and again it will be a negative value through there. Pop that in there, pop that in there, and we're going to pop that there. So this is in fact our new seed point here, which we then just have to feed into here and to here. And we've got a problem here, sorry, so that goes into there. So now we can offset our towers from the southwest corner by a certain degree, and also how far we come off the facade. Okay, now I'm going to be perhaps a little bit more excessively complicated, but I'll just do this as an exercise in order to finish what we started. Now what I'm going to do is that we need to introduce some floor slabs between the lift cores so that people can get out of the lift into the building through there. Now I'm going to, at the moment these are just sort of duplicated out according to a fixed dimension here, but I'm going to add another variable in here so I can adjust the width of these cores, the lift lobbies, sorry. So what I'm going to do is I'll change this to lift lobby width instead, and then I'll put a addition in through here. So the spacing of the cores will now be a product of the core width, which is over here, chasing that through, plus that. So we'll go in through there, connect that up, and that will be then the step number. Pop that into there, so that'll space them out nice and wide, and I'll pull that back down to maybe say 2.5, somewhere around there. Okay, we're going to try and start making this floor in here, and we'll try and figure out how we're going to do that. We might start with a point and do a three points through here. Now I'm going to get this point, and a point here, and we're going to define a rectangle. And I'll try and figure out how to do that with the available points that I've got. So what I might do is, although it seems a bit weird to do this, I'm going to start with that point there, and I'm going to move it back onto the facade. So I'll do that. I'll do a move. It will be in the Y direction, and it will be the length of the offset from the facade, core offset from tower. That's where we go there. So that will come in to here. And there's the point there. Okay, so now we've got a point there which will define one corner of our floor, and we can then move that one again. This dimension, which will be an X unit, it will be in the negative, and it will be then the distance of the lift lobby width. There we go. So I'll pop that in there, geometry goes in there. So one corner, two corner, and then the third corner we'll do from here. So we'll try and, where's that point there? That's that point there. So we'll duplicate that point, the width of the tower. So the width of the core, sorry. So we'll give ourselves a bit more space in here. Just pull all this rubbish down. And so that will be an X unit in the negative, and we'll pull in from the core width. So we'll just reduce that down. There. And where's our point again? There. So we'll do a move through there, the translation vector. Oops, there's our point, drops into there, and hopefully if we get a rectangle from 3 points, we'll start with A, B, C, and there's our rectangle that we've made, and we'll put a boundary surface on there so we can see what it is that we're doing. There's the rectangle there. So there's our floor surface. Now here's where it can actually get a bit complicated. The thing is that because we've got the stepped high-rise lifts, the ground, medium and high-rise lifts, we'll need all of the floors coming out of these lifts to get back into the building, but we won't need the same floors coming out from here or from here. So in fact we need a bank of floors to correspond with this bank of lifts, and then we need another bank of floors here to correspond with this bank of lifts, and then another bank of floors through here. So I've tested a few different ways of doing this, and I think what I'm going to do is I'll set up this as a bank of floors and imagine this as a bank of geometry that then I will duplicate across and then offset up the tower. So I'm going to duplicate up, across and up. So the first step then, what I'll do is I'll determine the number of floors going up through here. Now to do that, I'll borrow the division through here, determining the number of cores needed, and if I do a division through here, I'll take this rounded figure and I'll pull in the number of floors through here into there, and if we get then through there, so we'll need 13.3, so we're going to have to do a rounding again through there. So that's giving us a number of floors. So through there, 13. So whereas this is giving us the number of cores, we're working off that rounded figures again dividing it into the number of floors to give ourselves the number of floors per lift core. Now, because we actually want, this will give us the number of floors, but we want to add one so that we get a roof over the top of each bank of cores as well. We'll do a division, and we'll put a value of 1 through there, and we'll add that to there, and that will give us the count. We'll do a series, and that will be the counts, and the step number will be the floor to floor, which is up to here. So step number through there. And now what we have to do is give us a move, a translation vector, which will be Z direction because we're going up. So that will be there, that will be there, and we're moving this boundary surface. So there's our bank of floors. Now what we'll do is we'll move this bank of floors across. So we're going to set up another series for that. We're going to do the counts to be the same number as the number of lift cores we've got, so that will be the count. The step value will be the lift lobby width and the core width, so we'll do an addition through here. And where are we? So the core width will come in through here, there, and the lift lobby width coming in through here. So that will be our step value. And then our geometry, we're going to move it in the X direction. It'll be negative because we are going back this way. So we've got the series, we've got the step, we've got the move, and we've got the translation vector through there. And now what we have to do is pop that across there. Now we've got a trickiness with the data tree through here, so we'll put a graft into there, and then we've got 3 banks through there. Okay, now we're going to have to move these in a variable way. So this one will move up the tower 0 value, we don't want it to move. This will move up the value equal to this, and then this will be twice that value. So this dimension through here will be equivalent to, let's do a multiplication, the number of floors per lift, and then we also pull in the floor to floor, which is in through here, and we drop that in there. We pull up a series, and that's the value. The count will be based on the number of cores needed again. So we'll pop that in through there. We're going up a Z unit. We're going to do a move. It's a translation vector, and then that's the geometry through there. And we'll graph this again, and what you can see, it's the data trees are now aligning, and then we can turn off the previous moves, preview, and there you can see we have our cores stepped up through there. And I'll leave it there to finish this off in the next video.